So it's vertically stretching it by a factor of 2. It's making it longer vertically, correct? And if you had some points down here and some points up here, it would stretch it. If you had some points below the x-axis, some points above the x-axis, it would stretch it like this, right? Which is about the x-axis. That's why it's always about the x-axis, okay? Because you'd actually be stretching it about that x-axis. Just that these are all above, so you're not really seeing it as much. Okay? This one says graph y equals x squared. So if we graph the function y equals x squared, if I plug in 0 for x, I get 0 for y. If I plug in 1 for x, I get 1 squared, which is 1 for y. If I plug in -1, -1 squared is 1, so it's -1 and 1. And then 2 squared is 4. And then -2 squared is 4. So that's your basic y equals x squared graph. So for this one, it says, then replace y with 3y. So we're using replacement notation. So I'm going to y, I'm hucking it behind my head, and I'm replacing it with 3y. So my equation is y equals x squared. I'm taking this y, I'm getting rid of it, and I'm going to replace it with 3y. So if it's with the y, it's actually the flip. It's actually a vertical stretch by a factor of 1/3, because that's 3 over 1, right? I don't like keeping it over there. I always like moving it over, and then I can just say what it is. So I'm going to divide by 3. So there's a 1 here, technically, and I'm going to divide by 3. So I'm going to get y equals 1/3 x squared. So I'm moving points. So I'm moving points. I'm going to use mapping. And then it also wants me to describe the transformations after. So xy is going to become, is there anything done to my x here? No. So my x is going to stay the same. And my y is going to be 1/3 y. And then I can just punch my points in. So I have -2 and 4. So it's going to become -2 and then 1/3 times 4, which is -2 and 4/3. 4/3 is like 1.333333, right? So we're just going to sketch it. I'm going to use a different color. And then we have -1 and 1. So that's going to become -1 and then 1/3 times 1. So it's going to be -1 and 1/3, which is -1 and 0.33333. Zero, 0 is going to be 0 and 1/3 times 0. So that's 0 and 0. And then this is going to be 1/3, and this is going to be 4/3. Remind me once we've done horizontal stretches, I want to bring you back to this one, because this one's a special case, the x squared case, okay? Remind me to bring you back to this one. So it actually looks like it's getting wider, but what we're doing is those vertical points are being squished, right? They're being squished by 1/3, being 1/3 of the original. So it actually looks wider, but what we're actually doing is we're squishing the vertical points, which in turn is making it wider. And then describe the transformations. This is a vertical stretch by a factor of what? 1/3. About the x-axis. So this is by a factor of. You try 4. I'll give you the basic function. The square root of x, if I put a 0 in, it's 0, 0. If I put a 1 in for x, it's square root of 1, which is 1, so it's 1 and 1. And the next point I pick is 4 instead of like 3, 2 and 3, because those are going to give you decimals. So I pick 4 for x, because the square root of 4 is 2. So I go to 4 and 2. 1, 2, 3, 4. And then the next one I pick is 9, because it's the next perfect square. And the square root of 9 is 3. So the next one's at 9 and 3. 5, 6, 7, 8, 9. Now you try and draw the new graph and then describe the transformation. This one you're replacing y with 1/2 y, so this y is going away, and we're going to have 1/2 y equals square root x. But then we want to move it to the other side, so we're going to multiply by 2. So you actually get y equals 2 root x. So it's actually a vertical stretch by a factor of 2 about the x-axis. So our points, which are x, y, are actually going to become x and 2y, because you're stretching them by 2. So whenever you're stretching them by a value vertical stretch greater than 1, it's actually going to make the graph seem narrower because you're pulling all those y values up. And if you're stretching between 0 and 1, so like a half or 3/4, it's actually going to make the graph wider because you're stretching those y values down, right? So it makes it look wider. So if I plug in 0, 0, I'm going to get 0 and 2 times 0, which is 0, 0 still. So it's invariant. If I plug in a 1, I'm going to get 1 and 2 times 1. So I get 1 and 2. If I plug in 4 and 2, I get 4 and 2 times 2. So 4 and 4. And then 9 and 3. You're going to get 9 and 2 times 3, which is 9 and 6. Now remember with horizontal translations, we actually did the opposite, right? So if it was x minus 3, it was 3 to the right. If it was x plus 3, it was 3 to the left. And remember how I just said to you, if it's with the variable, it's also the opposite. So if it was like y minus 3, instead of moving the 3 over, we would have said, if it was y minus 3, we would have said 3 up. And if it was y plus 3, we would have said 3 down, right? I also just said to you, if we kept that half with the y over here, if the half was with the y, it's actually a vertical stretch of the reciprocal, 2, correct? But if I move it away from the y, I can just take the value, right? Y's are nice because you can always move it away from the y and just take the values. But x's, you can never move it away from the x. It's always stuck with the x, right? Because the x is in brackets, so it's always stuck with it. So your horizontal translations will always be opposite, and your horizontal shifts, or sorry, your horizontal stretches will always be reciprocals, because you can't move it away from that x. You can move the y over and take that value, right? But with the x, you can't. So your horizontal stretch is always the reciprocal of the value that's in front of the x, okay? Because you can't move it away from the x. It will always be there. So that's why this says here, horizontal stretches are in this form, right? So it's beside the x. Can I move it away from the x? No. I can't put it on this side. It would actually be a vertical stretch. You can't move it around from the f. So it's always with the x. So your horizontal stretch is always the flip. It's always the reciprocal. So if it were to have a 3 halves in front of that x, your actual horizontal stretch is going to be 2/3. Okay, you're going to flip it, always. Never changes. The y's you can move, and then you can take it or you can switch it if it's over here. But the x's you're always switching because they can't be moved. That's why I actually like the x's better than the y's, to be honest, because the x can never move. It always has to be the opposite. Y, you can keep it over here and say opposite, or you can move it over to the left side or to the right side, my left, and it would be the same, right? But the x's, it's always flipped. You can never move them. So this would be B stretches the graph by a factor of 1b about the y-axis, because it's always about the opposite axis. So my point xy becomes x over by, or a lot of people like it better, 1 over bx and y. You're just multiplying by the reciprocal. Now, if you just have a horizontal stretch, all right, so it's 5x. So we have a horizontal stretch by a factor of what? This is 5 over 1, so our stretch is 1/5 about the y-axis. Oh, this here is the 2x, so it's actually stretching it narrower or wider? Narrower, because it's a horizontal stretch by a factor of a half. Does it ever flip? Is it ever like 2? Does it ever just stay what it is? Like, does it ever just always stay with a horizontal? No, always flips. This is like the give me. People get it wrong on the test. They're keeping it all the time. Stop, stop. It always flips. It always flips. The only thing that doesn't flip is your reflection. You just say reflection about the, because there's no flipping. You can't flip. It's a negative sign. Okay? Some people are like, but does it unreflect? I'm like, no, then it wouldn't be there. Okay, so true, that has happened every year. Okay, horizontal stretch by a factor of a half about the y-axis. So my mapping is going to be xy becomes 1/2 xy. Remember, what you say is what you're doing, right? You're stretching it by a half. When you're moving points, you're going to stretch them by a half because you're moving them, right? So the only time it's backwards is when you're putting it back into, so they'll give you words and you have to put them back into the equation. So if it said stretch by a factor of a half, when you put it back into the equation, you'd say 2x. Okay, that's how you, only when it's going into the equation is it the opposite. But when you're going from words to mapping, you're doing what you're saying. All right. So -2 is going to become -1 when I multiply it by half, and my y stays the same. So I have -1 and 0. -1 is going to become -1/2, or -0.5, and 2. It's getting narrower, which makes sense, right? 0 stays 0, and 5 stays 5, because 0 times a half is 0. So this one is invariant. Oh, my straight lines are terrible today. And then, no, 4. 4 times a half is 2, and 0. Make sense? Like I said, when they're basic, this like just stretches or just, it's not bad. It's when you put them all together. So you need to know your stuff really, really well. So when you put them all together, it's just, oh, they're all this. You're not second guessing yourself. Do I flip it? Do I keep it? Okay. So this is that one that I told you to star on the previous one. It's going to be this kind, I'll show you why. So graph y equals x squared, then replace with 2x. So we're going to take that x, we're going to huck it behind, and we're going to replace it with 2x. So we're going to get y equals 2x squared. Am I right? No, what do I need to do? Bracket it, because I'm replacing this x. So it's actually what? We could write it as 4x squared, correct? But 4x squared is a what stretch? Vertical, because it's not with the x anymore. The 2x is a horizontal, because it's with the x. Both of those stretches will get you the same graph, actually. If you do them separately, right? You can't do them at the same time, that wouldn't work. But if you do them separately, you'll actually end up with the same graph. So if you're replacing it here, most people would say horizontal stretch by a factor of a half, which is true, correct? But I don't have that as your multiple choice answer, and you're like, Lepp, you did not put the right answers down here. You just gave us like 4 wrong answers. No, I gave you vertical stretch by a factor of 4, which is right. Okay? Only happens with that x squared. If there's a little f in there, the vertical can't be the horizontal and the horizontal can't be the vertical because you can't cross over the f, right? It's only when it's like an x squared or a cubed or like something like that where the function doesn't have a little f in it that when you replace it, it could possibly turn itself into a vertical. Okay? But if there's that little f in it, which is, oh gosh, I can't draw it backwards, f in it, your vertical cannot become your horizontal, and your horizontal cannot become your vertical. So when the f is in there, it's actually really nice because your stretches are just what they are. They can't commingle. But here they could. So this is a horizontal stretch. I'll show you how that they're actually the same. Horizontal stretch by a factor of 1/2 about the y-axis. We'll do this one first. So we're going to have xy becomes 1/2 xy. So it's just the x squared graph. So 0, 0, 1, 1, negative 1, 1, 2, 4. That is a 3. Negative 2, 4. Bless you. Oh my goodness, it's getting worse. Okay, y equals x squared. All right, now, if I take those points and I plug them in, 0, 0, so 0 times a half is 0, and then 0. So that would stay. If I plugged in 1, it's going to be a half times 1, which is a half, and 1. So I'm going to go a half and 1. If I plug in this, it's going to be negative a half and 1. If I plug in 2, 4, 2 times a half is 1, so it's going to be 1 and 4. And then negative 1 and 4. So that's my horizontal stretch by a half, correct? Now I told you that these are the same, did I not? That you should get the same? So let's see if I'm a liar. So this would be y equals 4x squared, right? So this is vertical stretch by a factor of what? 4. Because it's not with the variable, right? If we move it over, we can always keep our y's. So I just move it over and always keep my y's. Then I'm consistently doing the same thing. So it's over. It's not with the y, right? So it's a vertical stretch by a factor of 4 about the x-axis. So my coordinates are normally x, y for my mapping are going to be x and 4y. Now, if this is true, when I go to draw these green dots, it should make the red graph. Should it not? If I'm telling you what I'm telling you is true. So if I plug 0, 0 in, 0, and it's going to be 0 and 4 times 0, which is 0. So that's true. Now, am I going to get this exact dot here? No, but I'm going to get another dot somewhere on that exact parabola that would draw the same thing, right? So if I take 1, 1, it's going to be 1 and 4. If I take, now there is a point on this blue that if I filled it in, I'd get these 2 points, but it's going to be like a fraction one, right? If I plug in negative 1, 1, it's going to get me negative 1 and 4. And then those other ones up top will get me ones that are off this graph. But I actually get the exact same graph, do I not? So it's really only those ones with a little f, without the f that you really have to watch out. And it's more so like an x squared or an x cubed graph. Okay, we're going to go down to example 5. So this is the original graph. Describe the transformations that occurred to each if the original function is y equals 4 minus x cubed. 4 minus x cubed. So in front of that 4 minus x cubed, I have a 3. What is that? Vertical stretch. Remember, if I had a reflection, I'd have to apply it to the whole thing. I could bring it over and I could just apply it to the whole thing with brackets. Same thing here. If I have vertical stretch, I have to remember to apply it to the whole thing. So this is just a vertical stretch. Vertical stretch by a factor of 3 about the and if I did my coordinate, it would be xy becomes x 3y. Because I just do what I say to do my mapping. So that 2x in front, or that 2x in the brackets, it's in for x, right? So if it's in with the x and it's in for x, it's a horizontal stretch by a factor of 1/2. Horizontal stretch always flips. You don't have to be like, does it? Doesn't it? Always. Vertical stretch can be like, maybe. Horizontal always flips. Never doesn't flip. Never doesn't. That's a double negative there. Okay. Does not flip. I mean, always flips. Never doesn't is flips. Oh my gosh. Okay. Horizontal stretch by a factor of 1/2 about the y-axis. You are correct. So my coordinate xy is going to be 1/2 x and y. Just do as you say, right? Now as we start combining them, so we're going to have more stuff to say. Describe the transformations that occurred on the original function y equals x squared. So there's nothing that's on this. It's just a basic x squared function, just a basic quadratic. So now remember we have to go SRT, right? Stretches, reflections, translations. So is this -2 with my x? No. If it was with my x, what would it be? In brackets. So it's not. So if that's something you're going to mess up, then put your little x in the bracket by itself. Because if it was with the x, it would be in a bracket, and it's not. Okay? So what stretch is that? It's a vertical. Vertical stretch by a factor of 2 about the Is there a horizontal stretch? There's not a horizontal anything. There's just an x, right? So all the horizontals, there's nothing. It didn't affect the x. The x variable would actually, the x value on this graph doesn't change, only the y's, because nothing affected my x's. Reflection. Do I have one? Yeah, and it's not in the x, so it's a reflection in the x. Reflection in the x-axis, on the x-axis, about the x-axis, don't really care. All of those are true. And then this 3 is a vertical translation. Oops, it's supposed to be t. Vertical translation 3 up. As long as we always move everything to the right, the y's you do what they are, the x's you flip.
You wouldn't do that. Or is it like you can't like square the 2 and
You could cube the 2, and it would be 1/8 x cubed. Yeah, you could totally do that. So when it's an x squared, x cubed, x4, any of the basic polynomials, absolutely. And then it would become a vertical instead of a horizontal. Yep. B, what did I tell you? This is going to come up all the time, I promise you, on daily quizzes and on unit tests. What did I tell you about the horizontal translation? What has to be in front of the x? A 1. Is there a 1 in front?
Sorry for the interruption again. Grade 10 and through Q, please come down. These pictures taken in the library.
All right. So, yeah, they're in the library. Oh, I'm recording this. The pictures are in the library today. With the candlestick. You get that? No? All right. We got clue. Yes, you're right. So if I take a -2 out, you have to remember when you're taking that out, you're dividing, technically. When you're taking out a GCF or a greatest common factor, you're dividing the terms by it. So -2x divided by -2 is just x. And then 4 divided by -2 is -2. Remember that that sign flips, right, when you take out that negative? So this case, we actually don't have anything affecting verticals. We don't have a vertical stretch, we don't have a reflection in the x, and we don't have a vertical translation because everything is in the bracketed squared. And if it's in the bracket squared, it affects x, right? So there's no vertical anything here. This is all in the brackets. Some people will say, well, this is vertical. No, it's not. That whole thing is squared, so it's actually the x, right? Because this would be x squared before. Now it's this squared, so that's all x's. Okay? So stretch-wise, I have a horizontal stretch by a factor of what? 1/2, because it always is the reciprocal, always flips, about the y-axis. If you forget to take the -2 out, you'll get your stretch right, you'll get your reflection right, but you're going to get your translation wrong every time. And they'll have that answer there. I'll have that answer there. Reflection. It's a reflection in the y-axis because it's with the x. And then we have a horizontal translation. Oops, it's supposed to be a t. T is a horizontal translation to what? Right. We'll skip C because it's just translation. You guys try 7. Okay, so everything's on this side. If there was something with the y, I would move it over. That would be my very first thing I would do if it were me. So stretches. Do we have any stretches? Yes, we have a what stretch? Vertical stretch by a factor of 2 about the, yeah. Any reflections? No, there's no negative here and there's no negative there. So we'll just leave it blank. Translation. There's a horizontal translation 1 to the left and we're good because there's a 1 in front of the x. No idea why that's blinking. Okay. B, do we have any reflections or stretches? I got a little antsy because it's not reflection. No, there's no stretches. Do we have a reflection? Yeah, it's right here. And because it's before the F, it's a reflection in the x-axis. And then this is the vertical translation because it's not with the x, right? Vertical translation, B down. C, what do I need to remember to do? Take out the -1. You're all golden, and then the quiz comes and you're like, I forgot to take out the... Don't be those people. There will be a few on your quiz where they'll be, on your unit test, where they'll be, you have to take out a negative or you have to take out a number. What happens if it's a fraction? I get people on this one all the time. So it's y equals, pretend it's just this, 1/2 x plus 4. So we get y equals, everyone knows to take out the half, but then it's x plus what? Everyone says 2. 2 is not right, because remember, you're dividing. So it's, if it was a 2 in front, if there was a 2 here, it would be 2x plus 4, then it would be 2x plus 2, correct? But if it's a half, you're actually dividing by a half. And when you divide by a half, you're actually multiplying by 2, the reciprocal. Okay, so if you're that person who's like, I so said 2, and I would totally do 2 again if you let me, put a little star and be like, don't do that. Because 99.9% of the people will do that. Because it just looks so nice. It's like, oh, a half, pull that out, it's a 2. But actually, when you take out a half, you're dividing by a half, which means you're multiplying by 2. It's like 4 divided by a half, which is actually 4 times 2/1, which is 8. And I promise you the answer 2 will be there, right? Okay, back to this one. So we have y equals f, take out the -1, x minus 3. So we have, that's all with the x, right? So we don't have any stretches. We have a reflection in the y-axis. And we have a horizontal translation 3 right. So now we'll go to example 9. So words to equation, okay? So write the replacement for x or y, write the equation of the image. So we're going to write the replacement because if they ask you for the replacement, you need to know what that is. Replacement is what you'd replace the variable with. So when you do replacement, you always do the opposite actually. So it's because you're replacing it with that value, right? And our y's, we always bring it over. So we actually replace and then we bring them over right away. So remember when you're replacing them back in, you'd actually have to do the opposite. So horizontal stretch by a factor of 6 means my x would become what? 1/6 x. So I would get y equals f 1/6 x. Vertical stretch by a factor of 1/5. My y, which is this, because replacement notation, you're actually replacing that variable. My y would be replaced with what? 5y. If I just put it into my equation, I'd put it in as 1/5 and I put it on my right, correct? But if I'm doing replacement notation, I'm forcing you to put it in for y. So then it would flip. So you'd have 5y equals f of x. And then you divide the 5 over. So you'd get y equals 1/5 f of x. So if I didn't ask you for replacement notation, you could just put it in the right. But remember, if it was an already transformed graph, you'd have to apply that 1/5 to everything, right? You'd have to put it in brackets, just like you put that negative in brackets before. And you'd have to apply it to the whole transformed equation, right? Because it would affect your vertical translation. Do you remember that? Okay. And we'll do some practice of that for the test too. A reflection in the x. So what's it with? The y. So we have a -y. So y becomes -y. And a vertical stretch by 3. So instead of y actually becoming -y, y is going to become -1/3 y. So you'd have -1/3 y equals f of x. And when you move it over, y would equal -3 f of x. So unless I force you to do replacement notation, you could just do this. You could just put it there. That's absolutely fine. I'm just showing you this just in case it said replacement notation. You need to know that it would be the opposite, okay? But only if it said replacement. If you're just coming up with the equation, you could totally put it here. But remember, whatever the function is, you'd have to apply it to it. So if the original function instead was y equaled x squared plus 2, and I said you had a reflection in the x-axis and a stretch by 3, you'd actually have to go y equals -3 x squared plus 2. It would have to apply to the whole thing, right? And so you'd actually get y equals -3x squared minus 6. So remember, if it's a vertical stretch or a reflection in the x, and your original graph is actually transformed already, it's not just x squared, it's not just a basic function, you have to apply it to the whole thing. Okay? Remember that. I just made up an equation. This is just a random side note. Don't think it had anything to do with anything before. Yeah. Okay, we're going to flip to the next page where I think the homework is. Nope, 2 pages ahead. 3 pages ahead. And I'll tell you what to do out of this because you're not going to be doing the graphs part. Does someone have their textbook handy?